Everyone, in this video just going to go through some of the features in this Mars 80K. And so the first thing is it's a really large scene. So I always set my camera speed up to 8 and the camera speed scalar to maybe 1024 or 2048, somewhere around there. And once that's done, you can move around quite quickly. And the next thing I just want to do is if we come down and we start to go through, you'll see there's this little bit of popping in the atmosphere. I don't know if it's visible in the video, but at my end, there's a pop just there. So if we want to get rid of that, we can put in a console variable, which is this one here. I'll put that into the description, and then you can see that we can traverse through the atmospheric and the terrain-based perspectives of the sky without having any popping. All right. The next thing is the material for the actual planet is material instance, and if I just bring that one over, there's 3 exposed parameters here. The first one is the displacement amount. So you can see this is a really large value because this planet is so large, and that can just be taken up and down. And you'll notice that it creates a little boundary layer or a void of the atmosphere, so you can adjust the atmosphere dimensions here. So maybe 3400, if I flattened out the planet like this, then I might need to drop down my atmospheric radius here. So I'm just going to go to 3410 and just reset this to what it was before. Also, the displacement tessellation, this Mars static mesh sphere, if we just go and have a look, we can see it's about 100,000 triangles by default. And if I just deselect it in the viewport, we can see the actual displacement tessellation here. So if we drop that down to 0, we can see the base mesh. And as we step that up with whole numbers, integers, we're going to see basically the displacement map on here doesn't need more than about 2, or if you really want to max out any of the detail on the displacement map, 3 iterations of tessellation. But 2's quite good. The last thing that I just wanted to look at here with this map is this normal flatness. And so if you're at a place like over here, and the terminator, for instance, you can see this is a pretty hard terminator, and where the light goes into shadow, we're still picking up quite a lot. The normal map is, and the displacement map is picking up quite a lot of light features here, so you can control somewhat how much those are captured or exaggerated by adjusting this normal flatness. So you can go into the negative value if you want the light to essentially creep around the planet, and obviously go up if you want to kind of smooth this out. So that's what those features do. And then moving along, if you do want to adjust the light, this is just set up using a directional light. So you can press Control L and just move it around in the viewport as you like. The other option is to just obviously grab it and change it in here. Okay, so I think the last thing here to look at is the material for the star field. So this is the star field. Oh, that's the static mesh. Never mind. If I go to my materials, instances, and star field, I'll just shrink this down just to see what it is. The actual material here is there's a material that has this star field, and the tiling can be altered here if you want more or less stars. And this is run into a cheap contrast, and we'll see that this is actually parameters driving that contrast value, and that's actually controlling the mask. So that's going to control how much visibility we have of the stars. And then there's also a star brightness multiplier. Okay, so if we go back and we shrink this down, we can have a look at the star brightness. I'll just deselect these in the viewport. And so if we crank the star brightness up, we get, as we'd expect, brighter stars. And the star contrast here, this is quite sensitive, so you can see if we drop this down a little bit, we get the full detail of the star map. And if we crank it up, they dot out and fade away. Okay, go back to the defaults there. And that's it for the Mars here. Enjoy.